Greetings, everyone. I am Uday Sharma from the Triply Department of Institute of Aeronautical Engineering. Today, I am going to discuss about the topic turn-off methods of SCR and a classic commutation. Let us discuss what is an SCR. An SCR is a silicon-controlled rectifier. It is often referred as unidirectional semiconductor made of silicon. It acts like a switch for the turning on and off of the circuit in the electronics and electrical mediums. The SCR is also referred as thyristor. They are made up of three terminals, that is, anode, cathode, and an additional terminal called gate. The SCR consists of two p-type junctions and two n-type semiconductors. Two p-type semiconductors and two n-type semiconductors. It has three junctions where p-type n-type has junction 1, NP has junction 2, and PN again has junction 3. As this is a positive terminal, it is often referred as anode, and this is a negative terminal, N-type, it is often referred as cathode. The SCR term, the gate is provided supply to turn on the thyristor. We can only control the turning on of the thyristor. The turn off is not controllable. Let us see how an SCR works. The SCR mainly works in three conditions, three modes. Firstly, the method is when a cathode or negative side is supplied with the positive supply, or else you can say as the anode, the positive side is given with a negative supply. Here, both the ends has reverse bias conditions. So that does not allow any current to flow with it. This condition is called as reverse blocking mode. But there is a small leakage current as very small depletion layer forms. Between these layers, small amount of current is flowed through this circuit from the positive supply to the negative supply. This is also called as reverse leakage current. There are other two modes, first forward blocking mode and forward conduction. In this mode, the p-type is connected to the forward blocking mode. The p-type is connected to the positive supply, and the n-type is given to the negative. As we can see, the negative is connected to the negative, the positive is connected to the positive. Here, these conditions goes to the forward mode, forward condition mode, or forward bias. Here, the gate supply is not yet provided. Here, just the supply is given according to the terminals. A small, yet as here the current passes. Again, here the current passes. This junction becomes as thick depletion layer. Because this is an NP junction and the currents are reversely flowing with each other. The same process happens with this. A small amount of current is leaked forward. So we call the current leakage here as forward leakage current. This depletion layer depletes when a gate signal is given or a gate voltage is given. The depletion layer breaks and there will be no junction J2. Thyristor will become just a big P junction, N junction, and P junction. It contains only three junctions or three terminals. This layer completely depletes and allows the current to pass through it. We can see here the VI characteristics, how the depletion layers. We can see here the reverse characteristics. The thyristor is not on here. This is the leakage current we have discussed earlier. At this point, this is whole point. This point is a reverse blocking mode. At this point is a forward blocking mode. And here, this line is a forward conduction. This is a forward leakage current. Turning off of SCR. SCRs are also called as technically named as semi-controlled rectifiers. as we can only turn on the SCRs and turning off is not in our hand, or we cannot turn off the SCR. Turning off is also called as commutating in the terms of SCRs. There are multiple ways of commutating in an SCR. We have AC commutation. When the commutation varies from the input. If the input we supply is an AC input, because there will be the natural commutation, as we have a sinusoidal waveform, and when the negative supply is provided to the thyristor, it turns off automatically, naturally. So we call it as natural commutation. When the DC supply is provided, we have multiple methods of commutation like class A commutation, class B commutation, class C, class D, and class E commutations. These are also called as forced commutations, as we have an external supply is given to turn off these thyristors. Let us discuss the class A commutation. Firstly, let us see what is a circuit for class A commutation. We have a post, we have supply going here, supply. We have a thyristor connected to the anode, and positive supply is given to the anode. And to the cathode side, we have an inductor, capacitor, and a load, mostly resistor. As a positive supply is provided to the thyristor, the current flows. To turn on the thyristor, as we have discussed, the supply is provided. While the current is flowing through this circuit, the capacitor starts to charge. As is an energy storing device, slowly starts to get charged. Once the capacitor reaches its maximum or peak capacity, that is, when the capacitor is full, the capacitor searches for the discharging path. So it discharges, as this is the natural path provided by the circuit. The capacitor discharges. It gives the reverse voltage. It gives a positive voltage to the negative side, or it gives a positive voltage to the cathode of the thyristor. This makes the thyristor in the reverse mode, which turns off the thyristor. As we can see in this, as we can see clearly, the thyristor first, the supply is provided to the thyristor through the inductor, and it goes here. Let's the current flowing is I. As the capacitor gets charged, we know this, the positive charge and negative charge. Characteristic gets charged. It the capacitor gets charged and it changes its terminals. The negative cathode is supplied the positive voltage, which is equal to the supply voltage, as the capacitor shows exact amount as a supply voltage. So the thyristor gets turned off and the open circuit is formed. Open circuit is formed. This is the open circuit or the class A commutation of a thyristor. As you can see in this clearly waveforms. Here the gate pulse is given to the thyristor. As you can see, the gate pulse is given while owning the thyristor. We have clearly given the gate pulse. From here, the voltage starts. As you can see, slowly the capacitor starts to charge and it starts to release the inductor energy. Once the capacitor gets discharged, we can see the voltage in the thyristor also increases as the thyristor getting the reverse voltage, all the reverse voltage. And we have also the current going to zero, as this is the open circuit. We know that the open circuit current becomes zero and voltage becomes high. In this graph, we can clearly see that the voltage increases when the current becomes zero and the thyristor turns off. Thank you. This is Uday Sharma signing off.